So, very good morning for this lecture. I welcome everyone for AIML for electrical subject, electrical system, especially in application in Unit 5, application of power system in AIML. Nowadays is very booming in LSTM based power system application. Here today lecture we discuss with the LSTM based load forecasting. So today lectures first we start from load forecasting. Why need for forecasting? From the identify what are the type of methods are there for doing for load forecasting and basic LSTM structure. How we will apply LSTM in load forecasting concept. Uh, what is load forecasting? Load forecasting is the process of predicting the future demand. Predicting the future demand. In futures, example for in Chennai region, we have so many number of substations, especially in our area near to Alamadi substation is there. In Alamadi substation, so this year, say today, this month, today we identified this much load is consuming, but similar date next year we want to predict, or the same similar date next month we want to calculate how much possible load demand. What is the load demand for future? So that's the we want to mainly focus. So the load forecasting is simply say nothing but predicting future electrical energy demand. So based on our historical data. So in the historical data, this load forecasting, so where we will apply means in terms of especially power system planning and operation. So we want to extension of our power system network. In power system network, we want to add some more our existing system. Example for our existing system power abilities some in terms of 100 gigawatt. So in futures, we want to add, just we want to expand in terms of from 5 megawatt we want to add to this. So that places, so this type of study is very much helping. So we want to mainly support it for power system planning and operation and the energy trading and tariff design. So the energy trading, okay, so if we go for load forecasting, especially this region, the more demand is there means, so you are a energy inducer. So from this you want to make some, I will demand this much I am having able to generate power. So and also you fix the tariff. So the energy trading and the tariff design, and also in future this load forecasting, the renewable energy sources also we want to utilize and we want to integrate it to our normal grid. And also if load forecasting is there means the main advantage of this load forecasting is for to avoiding blackouts and optimally we can able to generate in our system, in our systems. Okay, and especially what are the types of forecasting? In the normally generally the forecastings are classified into three types. This is belonging to mainly duration. So how much we will use? One is short-term load forecasting, mid-term forecasting, long-term forecasting. The short-term forecasting we do for only within a day. Example, we start from minutes up to hour or day. Maximum 24 hours. What is your demand? So this only for just operation purpose only do for short-term load forecasting. Medium-term forecasting in terms of some weeks to months. So this is very much supported for scheduling and maintenance. The scheduling is nothing but we have many number of generators G1, G2, n number of generators. Especially we have four number of generators. In the four number of generators, which generator we want to turn on with optimal cost. So the load forecasting is mainly supported to turn on which generator is giving low cost and optimal performance. That is medium term generator and long term for you want the expansion of our system, our entire power system network. So especially supported for we want to calculate our capacity of the plant and also the infrastructure improvement development. That is load forecasting. Another one for if you go for traditional method. So if you not generally you can tell this year is 10 megawatt is priced. So the next year what's your expectation of demand is in this area. So that time is very difficult. General calculation, regression model, normal mathematical recurrency concept because this is easy to do with the help of some probability and regression model. But some such a model also suggests statistical methods. That is called traditional techniques in terms of ARIMA, regression models, or SVM. But this traditional model, what are the drawback is there means they are not able to deal for some non-linear relationship. The statistical data only dealing for if you give for any linear parameter. So from the linear parameter only you can able to do in terms of any temperatures, holidays, and human behaviors. And next one, the long-term temporal dependency. How fast this load affects future load. And the third one is main problem is what means the deep learning and the LSTM network is mainly supported this breaking of this the non-linear relationship and long-term temporal dependencies. Okay, this overcome we go for LSTM. The LSTM is nothing but long short-term memory. So this is with the help of working long short-term memory. So this is the remodification of our RNN network, recurrent neural network. So this mainly this RNN and LSTM, they're mainly supported for time series data. The time series data. The time series means we give for low duration curve. From the low duration curve, you can able to predict. So the entire last 6 months historical low duration curve is given to the input. So from the data, we can predict what is it next 1 month or 2 months demand. So the same similar way, the unlike standard RNNs, what means can remember important patterns, long sequence, and but relevant information sometimes is missing. Relevant information is sometimes missing. Okay, so this internal memory cells. So here, how will work means in terms of memory cells, input gates, and forget gates, and output gates. So the LSTM consists of in terms of some gates. The gates we store the previous data, especially the previous state. In terms of previous states, they identify previous what state is working, especially the in terms of memory cells, input gates, forget gates, and output gates. So based on this only, our function is working. With the help of LSTM, normally LSTM is say for neural networks that learn from the past to predict the future. The LSTM is major role in not only the power system and also nowadays is coming for future election also you can able to predict in terms of previous last 10 years who won the uh, winner of your Lok Sabha elections or Rajya Sabha elections. Okay, remember that's also possible to predict. The LS team is giving better results. So based on that, we will give for some ideas. The LS team is consist of input layer, LSTM layer, and a dense layer, and uh, training process. The input layer is nothing but historical load data. The input layer having historical load data plus what are the additional external variable in terms of the historical load data is nothing but load duration curve and the external variable is nothing but temperature or day of peak or humidity. Next, we come to LSTM layer. In the LSTM layer, the capture temporal dependency. So temporally we say for so what are the days, what are the hours, the load influencing, load variation is there. So that is also we want to identify it. And from the dense output layer and produce. Okay, so these are the things happening. So this places only this period, this season only, the load is increasing. So we want to identify with the help of forget gate and output is produced. Okay, that is the dense layer or output layer produces the forecasted load. So demand for the next hour or next day. So next we enter into so everything your structure is ready, your program is ready. Next we enter into training process. The model is trained with the help of root mean square error or median average point error. So with the help of that we will do for in terms of load forecasting. So general load forecasting consists of input layer, LSTM, dense and output. So next we start for in terms of algorithms. The first step is data collection layer. The data collection layer, so the data collection layer with the help of to collect historical or load curve, especially in Chennai city. Example for in the time stamp, that is time series data. In this time stamp, the data start from 1 1, okay, January 1, 2024. So this way per day or per month or per year we collect the data. So that time what load is there and that time what temperature is there, what humidity is there is a data collected layer. So this is the first step. So next one is data pre-processing layer. Once the data is collected, sometimes the data is mismatched or sometimes the data is missing. So that's what we want to do for the second step. We want data cleaning, that is data cleaning and data normalization and the feature engineering and the sequence generation. So the data cleaning is removing missing value. So the normalization is what means if any missing value, any missing data is there, that place. So based on your data, we want to fill the data. That also with the help of interpolation. And next one normalization with the help of the data is which it's pass from the maximum and the minimum limits 0 to 1. And next one we create sequence data for next 25 hours or 24 hours. So which is we require based on that we prepare for data processing layer. The third one is LSTM neural layer. The LSTM neural layer with the help of our gates, especially forget gate. With the help of the forget gate, we want to develop and we create the layers, LSTM neural. And the final one is dense layer. The dense layer process the extracted features, the maps of next hour load. So that is example for the input from LSTM is 0.45, 0.65. The output is predicted is 0.5 is according to normal scale. I will predict. Okay, that's in terms of Python or any platform you can. Next output layer, the output is forecast of the next hour. The scale prediction is 0.58. So that is our scaling. And next, what is the maximum load? What is the minimum load? Based on that, the maximum load is 1500 megawatt, minimum load is 1000 megawatt. The predicted load for next hour, so 1290 megawatt. So that is our in terms of really going for our LSTM layer. So after training that, when we stop this process. So that is mainly the training and optimization layer. The training which is the help of mean square error. So train the model 80% of data and the validation is we consider for 20, total 100%. 80% we have data, 20% we will do for validation purpose for database store. So this validation is with the help of mean square error. The mean square error with the help of the RMA values, how much we will allow, around 1500 megawatt. So the RMS is we allow for that less than 30 megawatt. And finally, we will show for what is our predicted scale for we will show in and complete it. Thank you.